back to another video with Arduino. Today we're going to be experimenting with the joystick and the servo motor and making a pretty cool project with both of them. So stay tuned and let's hop right in. So today what we're going to be making is a servo motor controlled by a joystick. So you can see when I move the joystick to the right or the left, the servo motor follows it. So I'm going to display the wiring diagram because all these wires are just too confusing to show you right now. So let's hop on the computer and look at the wiring diagram. Okay, so here's the wiring diagram. You may notice that there's a little bit more wires this time, but I made sure to color code it so that it's easier for you to see visually. So pause the video now if you want to see this, copy this down and plug it for your Arduino. Alright, so now let's hop into the code. So these are all initialization statements, as I have previously mentioned. In position, it's just setting the position to 0. These are initializing the values. These two are setting the x and y. Const is important for saying that it's going to be constant, right? So it's x pin and y pin, and we're setting those to A1 and A0. And this is for the x and y of the joystick. And these are floats, position A and position AA, and these are just holding decimals or whole numbers. So just like we saw with the ultrasonic motion sensor, serial.begin 9600 is important to ensure serial communication so that whatever you do to the joystick, the Arduino will take that as input and respond accordingly. So we attach the servo to pin 4 that we can see right here, attached to 4 with the purple wire. And we write 0 to the servo. So it's going to start at position 0, and we're going to delay 1000, which is delay 1 second. That's 1000 milliseconds. And now here we get into the loop. So I'll talk about this after I discuss position A and position AA. So we're going to start off with this. That's going to be 0, right? Position A, analog.read, well, analog read X pin. So we're just finding the X value, find the X value, and set it to position A or pos A. And then you're going to use that in the equation. So this is important, right? So pos A times 180 divided by 1023. So the 180 comes from the furthest most that the servo motor can go, which is 180 degrees because we're talking about linearly. And then 1023 is the furthest right that the analog can go. So the furthest X value for the joystick is 1023, and the furthest X value for the servo is 180. So now if you think about this, right? If I'm using the digital analog joystick, and I want the servo motor to go to the rightmost value. So I want it to go all the way to the right. I would use the joystick and move it all the way to the right as well. And so if I move it to the right, the furthest it can go is 1023. So position A, pos A is going to, once it reads it, it's going to say 1023. So that's the value. 1023 times 180 divided by 1023, the 1023 cancels, and you're left with 180. So the furthest most you move the analog joystick, the furthest most the servo motor will go. So that's how it goes accordingly. So the most right on the joystick goes to the most right of the servo. If we use position A as 0, 0 times 180 divided by 1023, that's just 0. And so this equation basically says whatever value you move the analog joystick to, the servo motor can copy it accordingly. And so if you think about this, right, since we're staying in like a linear plane, so 180 is the highest value, let's say this value was like a 190. Assuming that it can only go to 180, it would go past 180 if this was, let's say, 200 or 300. So that's why this is important to copy down, because it ensures that the servo motor stays within the range that you want it to. So position AA, and then you make sure position A is an int, and then you print the position. So now we go back up because this is a loop, and essentially what it's saying is just to write the position. So whatever position you got here, you're just going to map it to the servo. So the servo is just going to copy that position to move there. So now let's run the code. So you see how it's already moving. It's starting at 0. You can already see the numbers, so it's 0, 90. So if I want to move it to the right, it's going to move to the right. If I want to move it to the left, it's going to move down. I notice also something that if I try to move it up, it's or down, nothing really happens because there's no use of the Y value. See, it never says read the Y pin and then uses that value. So, but something else you can do is move it down and to the right, down and to the right, and that would move it slightly. So let's upload this to the Arduino and you'll see what I'm talking about. Alright, so here's Servo after it's been uploaded. You can see it uses a longer top compared to the one-piece top that the website uses. But essentially, if I move it to the right, left, I think it was positioned this way in the website. But essentially, it starts in the middle, move all the way to the right, left, that's 180 and 0. So here it is. If I move it slightly to the right or to the left, it follows it accordingly. Same goes for when I move it to the left. See how it moves? It's very precise with the movement. And then if I move it up or down, it doesn't do anything. But if I move it up and to the right, there's some movement. But yeah, that's it for this video. I might do a project or like a game with the servo motor, or I'll look at the smart robot that I got for Christmas. Let me know down in the comments which one you would like to see. I think the robot uses like the ultrasonic sensor, the Arduino, and overall it looks pretty cool. I'll release it in a few part series, but yeah, for this video that's going to be it. This is the servo motor and the joystick, and definitely don't forget to like and subscribe, and thank you for watching.